Right now, the El Niño 3.4 region is warming rapidly. The Walker circulation is weakening, and climate chaos is approaching faster than anyone predicted. Deep beneath the Pacific Ocean, something massive is building. A wall of warm water stretching thousands of miles is slowly pushing eastward towards South America. On the surface, you cannot see it, but the data does not lie. Every single monitoring region in the Pacific has warmed over the past month. Sea surface temperatures off Peru have flipped positive. Climate models that just weeks ago predicted a moderate event are now flashing warnings of something far more extreme. Scientists call it a potential super El Niño. But here is what has alarmed forecasters. Subsurface readings show a heat buildup that was not supposed to appear until 2030 at the earliest. The atmosphere is reorganizing itself in real time. By late summer, this invisible ocean shift could restructure weather patterns across the entire planet. California, Mexico, the Atlantic hurricane season. None of it will be spared. Is the world about to experience one of the most powerful El Niño events in modern history? Or is this just the beginning of something even worse? To understand what is coming, you first need to understand the engine that drives it. El Niño and La Niña are not storms. They are not hurricanes. They are not weather systems at all. They are climate phenomena that reshape weather patterns across the entire planet. At the heart of this system sits the Walker circulation. Think of it as the atmosphere's engine over the Pacific Ocean. During normal conditions, this circulation drives trade winds from east to west across thousands of miles of open water. These winds push warm surface water toward Indonesia, Australia, and the Philippines. Meanwhile, cold water wells up from the deep ocean off the coast of Peru. The system stays balanced. The climate stays predictable. That is La Niña. Stronger Walker circulation, stronger trade winds, cold water rising in the east, warm water pooling in the west. The pattern we have experienced for the past several years. But El Niño flips the script entirely. When the Walker circulation weakens, everything changes. Trade winds lose their grip. Westerly wind bursts develop near the international dateline. The cold water upwelling off Peru slows down because the thermal layer beneath the surface blocks it. That massive pool of warm water near Indonesia begins sliding eastward across the Pacific. Picture the ocean as a giant bathtub. During La Niña, the warm water piles up on one side. During El Niño, that water sloshes toward the other end, except this bathtub spans 10,000 miles. The energy contained in that warm water is almost incomprehensible. Here is why this matters far beyond the Pacific. When that warm water shifts position, it drags the atmosphere with it. Storm tracks relocate. Jet streams bend into new configurations. Rainfall patterns flip from one continent to another. Droughts appear where floods once dominated. Floods strike where droughts persisted for years. The Pacific Ocean does not just influence global weather, it dictates it. And right now, that dictator is changing its orders. The latest data tells a story that cannot be ignored. As of February 9th, 2026, every El Niño monitoring region in the Pacific Ocean has warmed over the past month. This warming is widespread. Scientists divide the equatorial Pacific into distinct zones to track ocean temperature anomalies. The readings from each zone paint a clear picture of what is unfolding. The El Niño 4 region in the Central Pacific remains below average, but it is warming steadily. The El Niño 3.4 region, the zone that scientists watch most closely for El Niño development, shows sea surface temperatures still below normal, but climbing significantly from readings taken just 1 month ago. The El Niño 3 region confirms the same warming trend. The El Niño 1+2 region off the coast of Peru has now crossed into positive territory. Warmer than normal water is appearing exactly where El Niño events historically take shape. The 2-week change maps reveal dramatic shifts. Significant warming has appeared off the Peruvian coastline. Island chains across the Central Pacific show rising temperatures. Waters that ran cold for years under La Niña's grip are heating up at an accelerating pace. Look at the satellite imagery without the technical overlays. Cooler than normal water still dominates the Central Pacific, but warmer than normal readings now stretch across the Eastern Pacific off South America. The contrast is unmistakable. The boundary between cold and warm is migrating westward month by month. This is textbook El Niño development. The pattern matches historical precedents almost exactly. Warm water is building in the east. Cold water is retreating toward the Central Pacific. Temperature anomalies are flipping from negative to positive in sequence across the monitoring regions. La Niña is not fading gradually, it is collapsing. The conditions that locked the Pacific into a cooler pattern for years are breaking down in real time. The transition timeline is now clear. La Niña weakens through spring. El Niño conditions strengthen through middle to late summer. By fall, the transformation will be complete. What happens at the ocean surface only tells half the story. The real transformation is happening hundreds of feet below the waves, where satellites cannot see and most people never think to look. Right now, a massive pool of warm water is building beneath Indonesia and the Western Pacific. This is not a small anomaly. This is an enormous reservoir of thermal energy accumulating in the subsurface, waiting to make its move. The physics are straightforward but powerful. Warmer water is lighter than cold water. It wants to rise. It wants to stay near the surface. And when the forces holding it in place weaken, it wants to move. That movement follows a predictable path, eastward, toward South America, across thousands of miles of open ocean. This process does not happen overnight. Scientists estimate this warm water will gradually slosh eastward over the next 6 to 9 months. By late summer and early fall, it will reach the Eastern Pacific in full force. That timeline matches exactly with peak El Niño development. The mechanism driving this transfer has a name: Kelvin waves. These are not surface waves you can watch from a beach. They are massive oceanic pulses that travel beneath the surface, carrying warm water eastward each time the trade winds weaken. The atmospheric data shows exactly what triggers these waves. Wind bursts developing over the Indian Ocean and Indonesia, trade winds losing strength across the international dateline, and multiple tropical cyclones forming in regions where reduced wind flow allows storms to spin up. Both the GFS and European models confirm the pattern. Another westerly wind burst is forecast to push eastward by late February into early March. When it arrives, it will trigger another downwelling Kelvin wave, another pulse of warm water heading east, another step toward full El Niño conditions. Each wave builds on the last. Each pulse of warmth reinforces the pattern. The chain reaction is already underway. The surface will catch up eventually, but the subsurface is already months ahead. The ocean tells one part of the story. The atmosphere tells the rest. And right now, the atmosphere is flashing warning signs that cannot be dismissed. The Walker circulation is weakening. Climate models project westerly wind bursts will continue developing well into early and mid-summer across the central, eastern, and western Pacific. The pattern shows up clearly in forecast imagery. There is a ribbon of orange and red stretching across the equatorial Pacific, and westerly wind anomalies are building where easterly trade winds should dominate. Scientists watch specific altitude levels to confirm these changes. At the surface, westerly winds indicate weakening trade wind flow. But the signature that matters most appears at 200 millibars, approximately 39,000 feet, the altitude where commercial jets fly. At this level, forecasters look for easterly wind anomalies. Westerly winds near the surface, combined with easterly winds aloft, signal one thing: the Walker circulation is losing its grip. Current model outputs show exactly this pattern developing through summer 2026. The atmospheric engine that has held the Pacific in La Niña conditions for years is sputtering. The geographic scope of the weakening extends far beyond the equator. Trade winds are projected to diminish north and south of Hawaii. Meanwhile, the Atlantic basin shows the opposite signal, with enhanced trade wind flow building across the tropical Atlantic. This contrast is a textbook signature of strong El Niño conditions taking hold. Velocity potential anomaly data adds another layer of confirmation. Upward atmospheric motion will be favored across the eastern and central Pacific through summer 2026. Rising air means instability. Instability means enhanced convection. Enhanced convection points to one outcome for the Pacific Basin: increased tropical cyclone activity. Western Pacific typhoons, Central Pacific hurricanes, Eastern Pacific storms, tracking toward Mexico and possibly California. The atmospheric reorganization happening right now sets the stage for all of it. The Walker circulation does not weaken quietly. When it falters, the consequences ripple across hemispheres. That ripple has already begun. Climate models do not panic. They calculate probabilities based on physics and historical patterns. But what the models are showing right now has forecasters paying very close attention. Compare two snapshots from the European model. On January 1st, 2026, the forecast indicated a weak to moderate El Niño developing by late summer. A significant event, but within normal boundaries, manageable and expected. Then came the February 1st, 2026 update. The numbers jumped dramatically. A big uptrend appeared across the ensemble projections, not just for June and July. The warming signal extended further into fall and beyond. The moderate forecast transformed into something more serious. Most ensemble members now indicate a low-end strong El Niño by August and September. But several members are projecting something far more extreme, a very strong event, the kind of El Niño that rewrites weather patterns for an entire year. The European seasonal forecast maps visualize the shift clearly. For May, June, and July, moderate to strong El Niño signals dominate the equatorial Pacific. For June, July, and August, the warming intensifies further. The signal extends into the central and eastern Pacific and reaches northward toward Tahiti and surrounding island chains. The subtropical Atlantic shows a corresponding warm signal. That pattern typically correlates with suppressed Atlantic hurricane activity. Near average named storm counts become likely. The Pacific absorbs the energy that would otherwise fuel Atlantic systems. But near average in the Atlantic does not mean safety elsewhere. The same conditions that quiet the Atlantic supercharge the Pacific. Enhanced convective activity, lower sea level pressures, and tropical systems spinning up where they rarely threaten populated coastlines. The models are not unanimous. Uncertainty remains substantial. But the trend line points in one direction: upward. The question is no longer whether El Niño will develop. The question is how powerful it will become. A moderate event changes weather patterns. A strong event disrupts them. A super El Niño rewrites them entirely. The models suggest all three remain possible. Before drawing conclusions, honesty about uncertainty matters. Climate science has limits, and one of those limits arrives every single year between early April and early June. Scientists call it the spring predictability barrier. During this window, climate models perform poorly when forecasting El Niño and La Niña development. The atmospheric transitions that occur during spring create noise in the data. Signals that appear clear in February become muddled by May. Patterns that seem locked in can shift unexpectedly. This is not a flaw in the models. It is a fundamental characteristic of how the climate system behaves during seasonal transitions. The same barrier explains why Atlantic hurricane season forecasts issued in April carry enormous uncertainty. Predictions made after July prove far more reliable because the barrier has passed. Right now, we sit on the front edge of that barrier. The forecasts showing moderate to strong El Niño development are aggressive. The exact magnitude remains genuinely uncertain. How extensive the warming becomes by late summer cannot be known with precision until the models navigate through spring. But uncertainty about magnitude is not uncertainty about direction. The consensus range provides clarity, even without exact numbers. At minimum, a weak to moderate El Niño appears highly likely. A strong event remains a genuine possibility. The warming trend is established. Only the final intensity remains in question. This is the moment to reinforce a critical distinction. El Niño is not a weather system. It is not a storm. It is not a hurricane or a tropical cyclone or any kind of rotating circulation. You cannot track it on radar. You cannot watch it make landfall. El Niño is a climate phenomenon. This is a planetary scale reorganization of ocean temperatures and atmospheric circulation, and it disrupts weather patterns across continents. It operates on timescales of months and years, not days and hours. Regardless of whether the final event reaches moderate or strong intensity, the impacts will be real. Weather patterns across North America will shift. The only question is, by how much? The Pacific Ocean does not change in isolation. When El Niño takes hold, the consequences spread across continents within months. North America sits directly in the crosshairs. During El Niño conditions, an enhanced subtropical jet stream develops over the Pacific, a river of atmospheric energy that aims directly at California, Central California, Northern California, Southern California. The entire coast becomes a target for Pacific moisture. From there, the jet stream extends into the deep south and southeast United States, carrying storms and instability across thousands of miles. The pattern flips regional expectations completely. Southern latitudes experience colder than normal temperatures, rain becomes more frequent, and snowstorms strike areas that rarely see significant winter weather. Meanwhile, northern states and Canada turn warmer and drier than normal. The cold Arctic outbreaks that dominated recent winters become less frequent as the polar jet weakens. This represents a complete reversal from what La Niña delivered. The brutal cold snap that gripped much of the country weeks ago was classic La Niña behavior. A strong polar jet, blocking high pressure over the western United States, Arctic air plunging southward. That pattern fades as El Niño strengthens. The jet stream reorganization carries consequences beyond temperature and precipitation. Tropical cyclone activity shifts dramatically between ocean basins. The Atlantic hurricane season faces suppression. Enhanced trade winds and unfavorable atmospheric conditions keep storm counts near or below average, and the Caribbean and Eastern Atlantic see reduced rainfall. Energy that would normally fuel Atlantic hurricanes gets redirected elsewhere. That elsewhere is the Pacific. Enhanced upward motion and convective activity supercharge the western, central, and eastern Pacific basins. Typhoons intensify in the western Pacific. Hurricanes spin up in the central Pacific. The eastern Pacific sees heightened activity from Baja California southward. The marginal risk of tropical systems turning toward California and Mexico increases through late summer into early fall. A scenario that seemed unlikely under La Niña becomes plausible under strong El Niño conditions. These changes begin within months. By fall 2026, the transformation will be unmistakable. The Pacific Ocean is reorganizing itself, not gradually, not theoretically, but right now. The data confirms it, the models project it, and the physics demand it. What began as subtle warming in scattered monitoring regions has become an undeniable trajectory toward one of the most significant climate shifts in years. The timeline is no longer speculative. La Niña conditions are collapsing through spring. El Niño strengthens through summer. By fall 2026, the transformation reaches full intensity. The warm water building beneath Indonesia will complete its eastward migration. The Walker circulation will weaken to levels not seen since the last major El Niño event, and the atmospheric patterns that billions of people depend on for predictable weather will shift into a new configuration. Uncertainty remains about the final magnitude. The spring predictability barrier stands between current forecasts and confident projections. Models that show strong El Niño today could moderate by June, or they could intensify further. Climate science cannot eliminate that ambiguity until the barrier passes and summer data arrives. But uncertainty about intensity should not obscure certainty about direction. Even conservative projections indicate significant disruption ahead. A weak El Niño still redirects storm tracks. A moderate El Niño still reshapes precipitation patterns across North America. A strong El Niño still suppresses Atlantic hurricanes while supercharging Pacific tropical activity. The differences between these scenarios are matters of degree, not kind. All of them change the weather millions of people will experience. This is how climate variability operates on a planetary scale. Massive energy transfers occur deep beneath the ocean surface. Atmospheric circulation patterns bend under the weight of shifting sea surface temperatures. Jet streams relocate across thousands of miles. Rainfall belts migrate from one continent to another. The Pacific Ocean contains enough thermal energy to restructure weather systems across the entire northern hemisphere. That restructuring is underway. The questions that remain are significant. Will this become a super El Niño that rivals the historic events of 1997 and 2015? How severely will California be impacted by an enhanced subtropical jet aimed directly at its coastline? What does this mean for the winter from 2026 to 2027 across North America? Will the Eastern Pacific hurricane season deliver storms to regions that have not faced direct hits in decades? None of these questions have definitive answers today, but all of them will be answered within the next 12 months. The climate system does not wait for human readiness. It operates on its own schedule, driven by physics that no policy or preparation can override. Monitoring continues. The models update monthly. Subsurface data reveals more with each passing week. By July, the spring predictability barrier will be behind us. By August, the true magnitude of this El Niño will come into focus. By fall, the impacts will no longer be projections. They will be lived reality for hundreds of millions of people. The warming has already begun. The Walker circulation is already weakening. The only question now is how far it will go. The Pacific is speaking. The world should be listening.